Now we can advance in the knowledge of Paratie plus analysis with Seepage, and we take the model of the previous video and we do some modification. Now suppose that we want to do the watering operation and minimize the pumping operation. This can be done by adding a soil plug inside the excavation. This can be modeled with Paratie Plus quite simply. So let's now modify a little bit the stratigraphy in order to provide a soil layer corresponding with the soil plug. Now the toe elevation is -15, and we consider a soil plug or an impervious barrier from -15, 2 meter, 3 meter, let's say 3 meter thick. So let's go to catalog and stratigraphy. Now we have one soil, we add additional soil, add soil, add soil. So we take the soil number 2, to which we apply the same soil property as in the surrounding soil, to elevation -12, and another soil to elevation -15. Okay. So what happens is that now there are three soils. One soil is from top down to -12, and then there is a soil layer from -12 to -15, and a third soil downwards. At stage number 2, we assume that there is through soil improvement, there is we realize we construct a soil impervious barrier here, like for example using jet grouting. Jet grouting operation will provide a much lower permeability in this part and increase the strength and also the stiffness. This can be done by modifying the property of this soil from this stage on. So it is we take an advanced feature of Paratie Plus and we take modify soil layer. We add a new modification from this section from stage 2, the side resisting, and the soil layer is the second one. What we do is to reduce, let's say, by 2 orders of magnitude the permeabilities. And also we provide some cohesion due to the cementation provided by grouting the soil, let's say 200 kilopascal. And as for elastic property, we may apply a stiffness multiplier, that is, let's say 200 times the original soil elastic properties. Okay. This modification is shown as a hatched zone here in the model, so you can see what happens exactly. We can also take a look to permeability table. Okay, you see that the permeabilities are modified. Now we must run analysis, but in this case the water, the well point, the quantity of water that should come in from this well point that we have designed before will be no longer appropriate, because due to the increase of the decrease of permeability of the whole model, the water would be much lower. So what we do now is, in this analysis, we disable this well point and we consider approximate condition of water removed along all the excavation surface, and we will see how much water will come in this case. So we run analysis, and the analysis is finished. So now we see that the pressure here are a little bit modified. What we can see is that if we look at the numerical value, the pressure at elevation -15 on the left side will be 99.35 kilopascal. That is very near to the pressure, hydrostatic pressure with respect to the original water table. So as expected, all the head loss will come along this soil plug due to the fact that its permeability is much lesser. This can be appreciated also by looking at the water pressures. The water pressures are essentially hydrostatics in the surrounding soil out of the soil plug, and the export pressure that essentially are related to head loss are the isocurves of are essentially concentrated in the soil plug zone. Now, now to see, of course, to consider this separate part, Paratie plus has generated a special mesh considering this discontinuity in soil properties. So the mesh is different. We use the flow, now we flow inspector to see how much is the flow required to be pumped off in this case. And it is 6 times 10 at -6. That is much lower than the value we estimated before, that if you remember was around 1 times 10 at -4 square meter per second. So the soil plug is has the role of reducing very much the amount of water to be pumped off. Of course, if the soil plug is made well, it is appropriate. Now, what is important is now we can also see now which is the water pressure along the model by using another tool that we call pressure inspector. Pressure inspector is simply a point where you can move around along the model and see how much is the pressure. You see that here the pressure out of the plug is essentially has the hydraulic head that reach the water table in the surrounding soil, and this is also what happens just below the soil plug. So below the soil plug, the water pressure are essentially governed by the head, the water table in the surrounding soil. So what happens is that the reduction of the water pressure then become dramatical in the soil plug, and out of the soil plug, in this zone, the water pressure just depends on the water table we applied in this part. So of course, now once we have reduced the requirement for pumps, our concern may be if this zone is actually stable due to the possibility of important uplift forces in upward in this zone. We can do, like, for example, we can check it by calculating the water pressure in some points around here. Okay, and so on. Again, we can calculate the resultant of the water pressure at the base of the soil plug, and so on. And then we must estimate the weight of the soil from the excavation down to the soil plug and see what is the safety factor. To do so, Paratie Plus offers a very simple yet effective tool to do this calculation using another inspector that we call piping inspector. With piping inspector, that is seems to be very similar to the flow inspector. What we do is we encompass the zone of interest and if the zone is can be calculated in this zone can be calculated the uplift safety factor. The program says that by simply clicking you will have all you want. So in this case the program calculate the U base, that is the resultant of the pore pressure at the base, and we calculate the soil weight and the water weight, if any, in this control volume, and calculate the ratio of the weight divided by the ratio of the pressure. This gives an idea of a safety factor. In this case we have 1.6 safety factor that for temporary that may be good. We remember that Eurocode may claim about 1.1. And also the piping safety factor is computed. The piping safety factor is the factor that is normally used to calculate the safety with respect to piping condition. If this is explained in the user guide manual. Let's take the user guide manual and let's go to okay. Let's go to the discussion about the safety factor. As I said, the uplift safety factor is the factor. It is defined as the ratio of the balancing load to the uplift hydraulic force. That is the ratio recommended by Eurocode, whereas the Terzaghi factor is essentially a ratio that is expressed in terms of just effective stresses. As normally this ratio reduced to the calculation of the exit gradient with respect to the is the ratio of the critical gradient with respect to the exit gradient. The details are contained here, and the Terzaghi safety factor must be around more than 3 normally. So we see that doing this quite simple calculation, we can have quite advanced response from Paratie Plus. Of course, engineering skill is still a necessary requirement doing this analysis. Paratie Plus is a tool to assist the user in doing his calculation and employing his skill. Thank you.